Okay, this video is going to discuss how to predict double displacement reactions using a solubility chart. What exactly is a double displacement reaction? A double displacement reaction starts with two compounds. So we have our two compounds here. We have AB and CD. What happens is A goes over and takes C's spot, so AD ends up as one of the products. C goes over and takes A's spot, so CB ends up as a second product. Make sure that the positive or the metal one is always written first, with the non-metal written after the metal. So here's our first problem. We have calcium chloride aqueous plus lithium carbonate aqueous, and this is a double displacement reaction. So calcium is going to come over and take the spot of lithium, and we end up with calcium and carbonate together. And you must check charges, +2 and -2, which cancel out. Plus lithium comes over and takes calcium spot, so lithium ends up with chlorine. Remember, do not bring the subscript with you. We want to just check charges to see if we need any subscripts, +1 and -1, so that one is good. Now, after you have the reaction all written, calcium chloride plus lithium carbonate goes to calcium carbonate and lithium chloride, we need to be able to label calcium carbonate and lithium chloride as solid or aqueous. So to do this, we need our solubility chart of your periodic table. Right here in the upper right hand corner, is our solubility rules, and that's what we're going to use to determine whether our substances are solids or aqueous water solutions. Here's a picture of that chart. Now on this chart, we have soluble things that are at the top, which means these are aqueous. So everything under here is aqueous, except over here we see on the right hand side there's exceptions. So if there's an exception to being aqueous, it means it's solid. So if I have silver chloride, then it would be a solid. However, if I have sodium chloride, sodium's not over on that side, it would be a aqueous solution. Okay, now down at the bottom of the chart, it says that it's insoluble. So these are solids. Unless they're on the exception side, then they are aqueous. So our substances, where it's calcium carbonate, the first thing we're going to do is look up the polyatomic ion of carbonate, and we can see that it is actually a solid unless it's in one of the exceptions. An exception is alkali metals and NH4+. Calcium is not an alkali metal, it's an alkaline earth metal, so it is not under any of the exceptions, so calcium carbonate is going to be a solid. Our second substance was lithium chloride. Chlorine is at the top. It is aqueous unless lithium is under the exceptions, which it is not, so lithium chloride is going to be aqueous. Label it. We said that calcium carbonate was a solid according to our chart, and lithium chloride is aqueous. The final and last thing we need to do is we need to balance our equation. So looking at this, I see on the product side I have 1 calcium, and on the reactant side I have 1 calcium. On the product side though, I have 2 chlorines. So I need to put a 2 in front of lithium chloride to have 2 chlorides. That also now gives me 2 lithiums, which we already have on the other side. And we have 1 CO3 on both sides. So it is now balanced. So we have completed that equation. Let's try another one. Okay, strontium fluoride reacts with potassium sulfate. So being this double displacement, we're going to take strontium over here and put it in place of potassium, and strontium ends up with sulfate, and we got to check the charges on that, +2 and -2, so those cancel out, plus Potassium goes over and takes strontium's place. So potassium ends up with fluoride, +1 and -1, so those cancel out. Now, once again, we need to go and check to see whether strontium sulfide and potassium fluoride is aqueous or solids. So back to our solubility chart. Here is our sulfate, and it would be aqueous unless it's under one of these exceptions. And sure enough, strontium is one of the exceptions. So if it's an exception, it's a solid. It's in a portion of the chart what makes it a solid. Our second substance is potassium fluoride. Now, fluoride is not on this chart, but since fluoride is in the same family as chlorine, iodine, and bromine, we can pretty much assume that they're going to have somewhat of the same reactivities. And since all three of these are aqueous, except with silver, mercury, and lead, then fluorine would be aqueous also. So coming back over here to this side, we have strontium sulfide, which is solid, and potassium fluoride, which is aqueous. Again, the last thing we're going to do is balance this. So 2 fluorines, I need to put a 2 in front of potassium fluoride, 2 potassiums on each side, and 1 of everything else, so it's now balanced. Okay, another example, lithium chloride plus magnesium iodide. So now we have lithium that comes over and reacts with, takes magnesium, pushes it out. So we have lithium iodide, +1 and -1, plus magnesium goes over and takes the spot of lithium. So magnesium chloride, but this time we have a +2 and a -1, so we need to switch them. So we get MgCl2. So our final equation is LiCl aqueous plus Mgi2 aqueous goes to Lii plus MgCl2. But now we still need to label the lithium iodide and magnesium chloride as aqueous or solid. Solubility chart. Okay, the chlorine for magnesium chloride is right here, and it is aqueous in this part of the table, we said, and magnesium is not one of the exceptions, so this will be aqueous. Our other substance is iodine, and iodine is also aqueous unless it's silver, mercury, or lead, which ours is not, it's lithium. So both of these substances are aqueous. So now we're going to go over here and put a Q after each one of these. Now this brings up a whole new situation. What we've just done is take 2 water solutions that are perfectly clear. We've added them together and we have still a perfectly clear water solution. So all of these ions that we learned, ionic solids dissolve in water and have ions floating around. So all these ions are floating around in a solution and nothing's changed. So this one is what we actually call no reaction. So for this one, what we want to do is actually rewrite the reactants, which is your starting material, put an arrow, and then put no reaction, because nothing changed. It's still the same substance. Okay, one last example now. Lithium hydroxide and aluminum chloride. Lithium is going to go over and push out aluminum. So lithium ends up with chlorine, +1 and -1. And aluminum is going to go over and take lithium spot. So aluminum ends up with hydroxide, +3 and -1. So switch them, AlOH3. So our whole thing is LiOH. We know it's aqueous, plus aluminum chloride is aqueous, goes to lithium chloride plus aluminum hydroxide. Now we need to find out whether lithium chloride and aluminum hydroxide are soluble or insoluble, solid or aqueous, so we can tell whether this is actually a reaction that's going to take place. So here's our solubility rules again. We have, for one of them, we have chlorine, which is with lithium, and this part of the table we said was aqueous. So lithium is not one of the exceptions, so this one will be aqueous. Then there's hydroxide. Hydroxide's at the bottom of the table, which this part of it we said was a solid, unless aluminum is one of these exceptions, which it is not. So aluminum hydroxide will be a solid. So now we're going to fill that stuff in. Aluminum hydroxide is a solid. Lithium chloride is aqueous. Then the very last thing, again, is to balance. Okay, so this time we have 3 aluminum hydroxides. So I had to put a 3 in front of lithium hydroxide to get 3 hydroxides. That also gives me 3 lithiums. So I need a 3 in front of lithium chloride. That gives me 3 chlorines, which we already have, 1 aluminum on each side, so we're all balanced. So our final thing, rewriting it so everybody can tell what we have. We end up with aluminum hydroxide solid plus 3 lithium chloride aqueous. And we're all done. Thank you for joining in this video, and good luck on balancing and predicting double displacement reactions.